We are living in an era of unprecedented technological advancement. Artificial intelligence is rapidly transforming our world, from self-driving cars to facial recognition software. One area where AI is making remarkable strides is computer vision. Computers are now capable of seeing and interpreting images with an accuracy that was once unimaginable. At the heart of this revolution is a powerful new technology called the Vision Transformer, or ViT. This groundbreaking architecture is changing the way we think about image recognition. ViT is enabling machines to understand visual information in a way that is more human-like than ever before. The implications of this technology are far-reaching. Imagine a world where medical diagnoses are made with greater speed and accuracy. Picture self-driving cars that can navigate complex environments with ease. Envision security systems that can identify potential threats before they even materialize. This is the future that ViT is helping to create. The Vision Transformer, or ViT, represents a significant leap forward in the field of image recognition. Unlike traditional methods that rely on convolutional neural networks, ViT leverages the power of self-attention mechanisms. This allows it to capture long-range dependencies within images, leading to a more comprehensive understanding of visual data. But what exactly is a vision transformer? In essence, it is a type of neural network that treats an image as a sequence of patches, much like words in a sentence. These patches are then processed by a transformer encoder, which uses self-attention to learn relationships between them. This enables ViT to capture global context and understand the overall meaning of an image, rather than just focusing on local features. The significance of ViT lies in its ability to achieve state-of-the-art performance on a variety of image recognition tasks. It has surpassed traditional CNNs in benchmarks like ImageNet, demonstrating its superior ability to classify and understand images. This breakthrough has opened up new possibilities for AI-powered vision systems across numerous industries. For many years, convolutional neural networks have been the dominant approach to image recognition. CNNs excel at extracting local features from images by using convolutional filters. However, they often struggle to capture long-range dependencies, which are crucial for understanding the overall context of an image. Vision transformers address this limitation by employing self-attention mechanisms. Unlike CNNs, which process images in a local and hierarchical manner, ViTs can attend to all parts of an image simultaneously. This global receptive field allows them to learn relationships between distant image regions, enabling a more holistic understanding of visual information. Another key advantage of ViTs is their ability to handle variable-sized inputs. CNNs typically require fixed-size images, which often necessitates cropping or resizing, potentially leading to information loss. ViTs, on the other hand, can process images of varying dimensions without any pre-processing, making them more versatile and adaptable. The impact of vision transformers is already being felt across various industries. In healthcare, ViT is being used to improve medical image analysis, leading to faster and more accurate diagnoses. For instance, researchers are using ViT to detect tumors in medical scans with remarkable precision, aiding doctors in making timely and informed treatment decisions. The automotive industry is another domain where ViT is poised to revolutionize existing technologies. Self-driving cars rely heavily on computer vision to perceive and navigate their surroundings. ViT's ability to capture global context and understand complex scenes makes it an ideal candidate for enhancing the perception capabilities of autonomous vehicles, leading to safer and more reliable self-driving systems. Beyond healthcare and automotive, ViT is also finding applications in security and surveillance. Its ability to identify and track objects with high accuracy makes it invaluable for tasks like facial recognition, anomaly detection, and crowd monitoring. In industrial automation, ViT is being used for quality control, defect inspection, and robotic manipulation, improving efficiency and productivity in manufacturing processes.